In this video, we're going to go over the Fibonacci sequence equation. So f of 0 equals 0 and f of 1 equals 1. So that's slightly different from the previous video I did on this Fibonacci sequence, but we'll just use these facts. So f of n equals f of n minus 1 plus f of n minus 2 when n is an integer bigger than or equal to 2. So an example of this would be f of 2 will be f of 0 plus f of 1, which is 0 plus 1, which is 1. F of 3 is f of 1 plus f of 2, which is 2. F of 4, 1 plus 2 is 3, and so on. So now we're going to find an f of n value. So let f of n be r to the n. So this is like differential equations, the way we're solving this. So let's plug that in to this equation. So we have r to the n equals r to the n minus 1 plus r to the n minus 2. So all we're doing is just plugging in n minus 1 and n minus 2 into this r, in r to the n. So because this is n minus 2, we want to multiply both sides by the negative version, which is really 2 to the minus n. We multiply that through, we get r squared equals r plus 1. So this is r to the first because n minus 1 plus 2 minus n, the n's will cancel. Negative 1 plus 2 is 1. So now let's move r plus 1 to the other side, so we have r squared minus r minus 1 equals 0. So let's do the quadratic formula. So that would be negative b, which is 1, plus or minus square root of 1 squared, b squared is 1, minus 4ac all over 2 times a, which is just 2. And 1 minus negative 4 is just square root of 5, just 5 in the square root. So this means r1 is 1 plus square root of 5 over 2, and r2 is 1 minus square root of 5 over 2. So we'll use that in building up our equation. So we have f of 0 is 0, and f of 1 is 1 from the beginning. And now we have f of n. Well, that's just a multiplication of these blocks, so that would be, or raised to the power of, so that would be a times 1 plus square root of 5 over 2, all to the n, plus b times 1 minus square root of 5 over 2 to the n. So now let's plug in n equals 0. So f of 0 equals 0, so 0 on the left-hand side equals anything to the 0 power is just 1 times 1, so that's just a plus b equals 0, which means that b is minus a. So that would be useful in a little bit. Let's plug in n equals 1. So on the left-hand side, we have 1 because f of 1 equals 1. So then we have a times 1 plus square root of 5 over 2 to the first, plus b times 1 minus square root of 5 over 2. And now we're going to multiply both sides by 2 to cancel out the fractions. So we have 2 equals a. We're going to multiply that out, plus square root of 5 a plus b minus square root of 5 times b. And now we're going to use that b is minus a. So we have 2 equals a plus square root of 5 times a minus a plus square root of 5 times a. A and minus a will cancel. Square root of 5 times a plus square root of 5 times a is 2 square root of 5 times a. Now we're going to divide by 2. So now we have a is 1 over square root of 5. And from this equation, b is minus a. So that's b is minus 1 over square root of 5. So we have f of n will be 1 over square root of 5 times the golden ratio to the n power, plus we have minus 1 over square root of 5 times 1 minus, write that smaller, 1 minus square root of 5 over 2 to the n power. And that is the equation for the nth Fibonacci number, and that's the end of the video.